All right. Guys, we were considering the second case when delta is the discriminant of the quadratic equation is 0, right? So we have equal roots. That is m sub 1 equals m sub 2 equals a minus b over 2a. And if you remember this, okay, now we got the first solution and we need the second solution, right? And another solution that is independent of this solution. So these two things are linearly independent. Since it's the second order differential equation, then these two solutions constitute, what is it, fundamental set of solutions of this differential equation. So again, let me just write here, we are talking about this differential equation, right? Ax squared y double prime plus bx y prime plus cy is equal to 0. And when we are looking for, when we're calculating this u, it should be in standard form, right? Standard form means the coefficient of this y double prime should be equal to 1. To bring this into the standard form, I should bring this into this form, y double prime plus p of x y prime plus q of x y is equal to 0. So here, what is p? This p of x is equal to bx over ax squared, right? I'm going to just bring it into this form. So which is equal to b over a times 1 over x. X cancels each other, b over a is just a constant number, 1 over x. So now if I evaluate this thing, so here we have integral p dx is equal to integral, what is p, is equal to b over a times 1 over x dx. Now b over a is just a constant number, right? And if you integrate this 1 over x, that's equal to natural logarithm of x. And since we know that we are looking for the solution on the interval from 0 to positive infinity, so I don't have to put here absolute value sign, right? Because we know that x is non-negative. So now if I substitute here, then what we have here? E to the power negative minus this thing, integral p dx is equal to b over a natural logarithm of x, which is equal to e to the power natural logarithm of x to the power minus b over a. And by using the property of a from calculus, right, that's equal to x to the power minus b over a. So the whole thing is equal to this, right? So if I continue here, let me change marker. So this u is equal to integral. Instead of this thing, here we have x to the power minus b over a over, what is y sub 1 is equal to x to the power m sub 1. So actually it's just equal to m, because m sub 1, m sub 2 is equal to this, just equal to m. So that's equal to x to the power 2m sub 1, right? And here we have dx. All right. So now if we simplify this, here we have integral, right? And the x to the power minus b over a, right? Minus 2m sub 1. And here we have dx. Okay. Now, as see here, 2m sub 1. Am I missing something? No. Okay. I can simplify this. So let me just write here minus b over a minus 2 times m sub 1, which is equal to minus b over a minus 2 times, what is m sub 1? M sub 1 equals this, right? So if I substitute here, we have a minus b over 2a equals 2 cancels each other. Here we have minus b minus minus b. That's equal to plus. This is equal to 0. So here we have, what is left here? Minus a over a. So this thing is equal to negative 1. So that is equal to integral 1 over x dx, because x to the power negative 1 equals 1 over x. And we know that that's equal to natural logarithm of x. Okay, so let me just open a small window here and also change my cancel color. So now we can just write then. Now what is the solution of the given differential equation? That is c sub 1 times x to the power m sub 1. We know what is m, that's equal to a minus b over 2a, plus c sub 2 times y sub 2. What is y sub 2? Y sub 1 times u times x. So that is x to the power m sub 1 times, what is u? That u is equal to natural logarithm of x. So here we have natural logarithm of x. So this is the solution of the given differential equation if the auxiliary equation's roots are equal. Okay. So this is the second case. Guys, also let's see the third case, and after that we will see a few problems related to this. Okay, Yihin, do you have any question?
No, sir.
All right, thank you very much. Smart boy, you understand everything. Papaya is here now. Let's continue. Now we will consider the third case. So the third case is, what is it? Delta is less than 0. Okay. At the time, we will have two different solutions, right? So m sub 1 will be equal to, what is this? Something here we have complex. So let's say it is in this form, alpha plus I beta. And m sub 2 will be alpha minus I beta, right? Because we have complex roots here, because this discriminant is less than 0. And you can just write this in terms of A, B, and C, right? Because we know what is delta, you know what is alpha here. Anyway, so if the roots are complex, then we will have these roots, right? So what will be the solutions then? Here, this y sub 1 will be x to the power m sub 1, which is equal to x to the power alpha plus I beta. Y sub 2 will be x to the power m sub 2, which is equal to x to the power alpha minus I beta. Right? Now, if I just write the solution of the given differential equation, then we will have here c sub 1 times x to the power alpha plus I beta plus c sub 2 x to the power alpha minus I beta. Anything missing here? Yeah, alpha, right? And as you see here, x to the power alpha, x to the power alpha. Alpha is a real number. We have nothing wrong with this. And it's a common factor. I can just take this out. Here we have x to the power alpha. So here we have c sub 1 x to the power alpha I beta plus c sub 2 x to the power minus I beta. Right? Now, by making some trick, I can change this into another form so that does not involve any of this imaginary number. Okay. And once again, you should remember that Euler's equation, right? If you remember, we have e to the power ix is equal to, what is it? Cosine of x plus I sine of x. So I'm going to make use of this Euler's formula and just to transform the solution into the simpler, the different form that does not contain, what is it, I. So using this identity, right, actually this is an identity. So here we have x to the power I beta, right? I can just write it as e to the power natural logarithm of x to the power I beta, right? And we know that because e, here we have the basis e, they cancel each other, is equal to this. I'm doing nothing here. So now, by using the property of, again, natural logarithm, this power comes to the front, so I can write it as e, right, to the power I times, let me just write this in this form. Here we have beta times natural logarithm of x, right? So here we have I beta, here we have I times beta, natural logarithm of x, natural logarithm of x. Now it's exactly in this form, right? But instead of x, here we have beta times natural logarithm of x, right? If I just write here alpha, here we have alpha equals this. So if I just write this in terms of cosine and sine, here we will have cosine of beta times natural logarithm of x plus I sine beta times natural logarithm of x. Okay. So in a similar way, x to the power minus I beta, right? The similar way, I can just write it as cosine of beta natural logarithm of x minus I times sine beta natural logarithm of x. Okay. So now, just making some trick, not trick actually. Here, for example, because this is the general solution of the differential equation, right? And if I just substitute some numbers, like say for some constant for c sub 1, for c sub 2, some specific numbers, it produces also some solutions of the differential equation. For example, let's say if c sub 1 equals c sub 2 equals 1. Okay, let me change my... If it is so, what we have here? We get one solution here, right? Let's say let me just call this y, one solution, right? If c sub 1, c sub 2 equals 1. Here c sub 1 equals 1, right? X to the power I times beta equals this, right? So here we have plus, here we have minus, right? So these parts, they cancel each other. What we have here? Here we have 2 times cosine of beta natural logarithm of x. Right? And how about if I choose like this? Let's say c1 equals 1, c2 equals negative 1. Okay, c1 equals 1, c2 equals negative 1. Or c1 equals 1, all right, this one is negative 1, right? Okay, so what do we have here? At the time in front of this one, it will be minus, cosine, cosine, they cancel each other. Here it will be plus, so we get another solution here. So that is 2I sine of beta natural logarithm of x. Okay, let me just write here. Actually, these are different. I can just write here anything. For example, let's say it is y sub 3, y sub 4. These are also solutions, right? Solutions of the given differential equation. And also we can show that on the given interval, these two functions are linearly, or is it independent? By multiplying this by any constant number, I cannot produce this function, right? And how can I do that? You just check this Wronskian determinant of this y sub 3, y sub 4. You will see that this will be different from 0. You'll have a kind of function here. It's not identical equal to 0. That means that also these two things are linearly independent. Okay. And that means that also they constitute independent set of, or is fundamental set of linear independent solutions of the given differential equation, right? So that means that then the general equation of the given differential equation would be x to the power alpha, x to the power alpha times c sub 1 times cosine of beta times natural logarithm of x plus c sub 2 times sine beta natural logarithm of x. Actually, this gives us the general solution of the given differential equation, that is Cauchy-Euler equation. Okay, for this case. Actually, whatever you find this, any solution can be expressed as this, in this form. Okay, and this is how we solve Cauchy-Euler equation. Guys, that's all what you're going to study in this section. Okay, now we have examples. We are going to consider some different examples. If you have any question, please you may ask now. Otherwise, I'm just going to move to the problems. Okay. Chevitia, are you there?
Yes, sir.
Any question?
No, sir.
So Chevitia, I have a question for you. Can I? So you remain silent. Okay, Chevitia. Try to ask a question. I'll give you some time. Anyway, guys, let's move to the problems. The first problem is about distinct roots. And first, we can recognize that A is equal to 1, B is equal to -2, C equals -4, right? So here, and in the standard form, here A is equal to 1, B is equal to -2, and C equals -4, right? So what we have here we have x squared y double prime minus 2x y prime minus 4y is equal to 0. Okay, so we're going to solve this. It's homogeneous equation. So the first thing we have to do is, as you know, we are seeking for the solution as x to the power m, right? When I just substitute here, what do we have here? We have this equation, right? This is a m squared plus b minus a m plus c is equal to 0, right? If you remember from here, what is our equation? So here we have a m squared plus b minus a m plus c is equal to 0. That's our quadratic equation, right? So from here, what is a? A equals 1. So here we have m squared, b equals -2, -2 minus 1, so that is minus 3m, and c equals -4. -4 is equal to 0. It's just a quadratic equation. By factorization, we can solve this. -4 times 1 equals -4. -4 plus 1 equals -3. So it is m minus 4, m plus 1 is equal to 0. Or m sub 1 equals -1, m sub 2 equals 4. Then what is the solution of this differential equation? That y of x is equal to c sub 1, x to the power -1, plus c sub 2, x to the power 4. That is the solution of this differential equation. Okay, and this thing, if you differentiate twice, put here, differentiate once, put here, and evaluate this expression, it will be exactly equal to 0, identically equal to 0. That means that for every value of x, left-hand side is equal to right-hand side. Okay, that's the first example. Another example, second example, I use different color, I like blue. So here, what is our a here? So a is 4. How about b? B equals 8, and c is equal to 1, right? So our differential equation is 4x squared y double prime plus 8x y prime plus y is equal to 0. So in the first step, we need to form our auxiliary equation, right? That's equal to a, that is 4m squared, and plus here we have b minus a, that is 8 minus 4, so it is plus 4m, and here we have c, so plus 1 is equal to 0. And I'll see here, if it's just a perfect square, right? I can write it as 2m plus 1 squared is equal to 0. Or that is m is equal to negative half. Right? So now we know that when it is so, this first solution will be x to the power minus 1 over 2, m sub 1. And how about the second solution? The second solution will be x to the power minus half times natural logarithm of x. Right? Again, we are solving this. Where is it? On this interval. Right? That is the interval of solution. Then dot, dot, dot. The solution of the given differential equation is c sub 1 times x to the power minus half plus c sub 2 times x to the power minus half times natural logarithm of x. Okay? All right. Another example that is for complex roots, okay, an initial value problem. So from here we can identify that A is equal to 4, right? And how about B? B is equal to 0 because we do not have y prime here. And C is equal to 17, right? So the auxiliary equation will be, what is it? 4m squared, right? Plus 17 is equal to 0. Okay. So from here, m squared is equal to minus 17 over 4, right? Or from here, m equals plus minus square root of 17 over 2i. Looks a bit different, but all right. I see here we have a small problem. Let me correct this. Is it recording? Okay, good. All right. So this A equals 4, B equals 0, C equals 17, right? And that is our equation. Well, our mistake here is AM squared plus B minus AM plus C is equal to 0. What is A? A equals 4. So here we have 4M squared. And B minus 4, B minus A, that is 0 minus 4, that's equal to minus 4, right? M. Plus C equals 17. That is equal to 0. Okay, actually here we do not have B. Here we have B minus A. Just confused here. I confused here. So we need to have B minus A. Okay. It looks like actually our typical that quadratic equation, but here we have B minus A, not B. Anyway, to solve this one, what we have here? Here we have, I can just solve this as 4m squared minus 4m plus 1 is equal to minus 16, right? And this thing is 2m minus 1 squared equals minus 16, right? So from here, what is 2m minus 1 equals plus minus 4i, right? If I just say to this side, then m1 will be equal to, it is plus 1 plus 4i over 2, and the m sub 2 will be 1 minus 4i over 2. two solutions. Okay, or m1 equals 1 over 2 plus 2i, m2 equals 1 over 2 minus 2i. All right, so that is, what is it, our alpha. This 2 is our beta, right? And if you remember, that is a third case, right? It is this case. So this beta is equal to that thing, this is our alpha, right? And here we have natural logarithm of x. How do you write the solution of this differential equation? Then this y of x will be x to the power alpha. Alpha is 1 over 2, and c sub 1. Here we have cosine of beta. Beta is 2 times natural logarithm of x plus c sub 2 sine 2 natural logarithm of x. Sorry. Okay. So that is what we have here. And I can just bring this inside and export anyway. So that is an initial value problem. So also now we need to find the value of c sub 1 and c sub 2, right? To do this one, first, right? So if x equals 1, if you evaluate this, y of 1. If x equals 1, this thing is equal to 1, right? And we know that natural logarithm of 1 is equal to 0. And also this is 0, is gone. Cosine of 0 is equal to 1. So that is c sub 1 on the left. On the right hand side, what we have? It is negative 1. So c sub 1 equals negative 1. All right. Now the second one, we need to find the value of c sub 2. To do this one first, I need to differentiate this. Okay, it is not like this, right? Okay. All right. So first we need to differentiate this, and after that evaluate the derivative of this function at 1. We will find the value of c2. All right. If we differentiate this, what do we have here? Y prime of x is equal to, okay, we will finish in 5 minutes. First, we need to differentiate this. That is 1 over 2 times x to the power minus 1 over 2. And here we have c1 and the cosine of 2 natural logarithm of x plus, okay, here we have the same thing, right? Plus, here we have x to the power 1 over 2 and differentiate inside. Actually, here with c sub 1, it is negative 1, so I don't have to write c sub 1 again, it's just negative 1. Now, if you differentiate inside, here we have minus, right? Cosine. First, I need to differentiate this thing, that is 2 over x, right? So that is 2 over x times, and differentiate this with minus plus sine, right? It is 2 natural logarithm of x, right? Plus, if you differentiate this thing, it is c sub 2, right? Again, it is 2 over x times cosine 2 natural logarithm of x. Okay. Now from here, y prime of 1. What is this? This thing is equal to 1, and also this thing is equal to 1. And here we have sine, right? In sine, because the natural logarithm of 1 is equal to 0, and this thing is equal to negative 1. So because it is 0, it is negative 1. So here we have negative 1. Plus, second part is equal to 0. Also, this thing is equal to 0, right? And also this is equal to 1. So it is 1. So here we have 2c sub 2, which is equal to, on the right hand side, we have minus 1 over 2. So if you just take this 1 over 2, then what is c sub 2? C sub 2 equals 1 over 4. Okay. Now, dots, dots, dots. The solution of the given initial value problem is x to the power 1 over 2. And here we have minus cosine of 2 natural logarithm of x, right? And here plus 1 over 4 sine 2. All right, here we have 2. Okay, natural logarithm of x. Okay, that is the solution of the given differential equation. Guys, do you have any question? That's all for today. Okay, Seraput Çevitya, how many people we have here? Participants, 9. Everybody is always almost here. Let me